Let's start. Hello, everybody. Thank you for coming out tonight. We really appreciate it. My name is Kevin Murphy. This is Trail Structures Building with Native Stone webinar. I just said my name's Kevin Murphy, and I'm going to be presenting alongside my partner in crime, John McLaughlin. Go ahead
Hello.
and wave to us. And before we get started, I just want to say thank you to Liberty Subaru for funding this event and making this possible for us to put this on for you. So without further ado, let me tell you a bit of background information about myself. Me and John are both AmeriCorps members with the New York, New Jersey Trail Conference this season. This is my first season as a trail crew member. I work at the Palisades crew, and this season our main challenge at Palisades has been building crib walls. So that's been my major focus this season, educating my crew members on that. And we also had some experience during training building some stone steps in at the Washburn Trail in the Hudson Highlands, and as well at Harriman State Park. So I'll let John take it away and tell you about himself.
Hey, yeah, my name is John McLaughlin. Initially, I was working at the Taconic region at the Washburn Trail with the trail crew. My time there, I spent working on mostly staircases and just started to work on crib walls. But unfortunately, I got injured, and so now you can find me on the weekends at Breakneck Ridge at the trail there, helping out the stewards. Yeah, and that's me.
Okay, so we just want to set some guidelines for participation in our Zoom meeting. If you have a question or you need us to repeat something, explain something a little bit more, you can put it in the chat, and we'll have someone monitoring that throughout the session. Or you could raise your hand if you go to your Zoom tab and click on participants. You can raise your hand, and we will address that. And no, I do not know the Jolly Rovers. Is that a band? Maybe I'd like them. Sylvia or Norma, sorry, Silva. Okay, let's go on. Okay, yeah, to start, let's take attendance. Everyone, if you could please type your name into the chat box and send to everyone in the meeting. Let's take a minute to do that. Okay. So let's take a look at what we're going to cover overall today. So we're going to look at trail issues, problems we encounter when laying out or building a trail. We're going to talk about how the issues are addressed, mostly through stone structures, because that's what this is about. And then we'll get into a little bit about how to build structures. The nature of a webinar is it's very obviously we can't do any hands-on things. So our what we're going to cover, it can be kind of limited, but if you need me to do any extra explaining or something, just please let us know. So let's take a look at, oh, sorry, no. So by a raise of hands, is everyone pretty familiar with the Trail Conference? We're all familiar with the history. I know I heard that some people are longtime volunteers here. If you're not familiar, we were founded in 1920. It's almost our 100th birthday on the 19th. We're a volunteer-powered organization that we currently maintain about 2,000 miles of trails, sorry. And here is where we work this is our headquarters, the Darlington Schoolhouse in Mahwah, New Jersey. So now let's take an overview of trail building and what the end goal is when laying out a trail. So Trails should rely on the minimum trail building required to make users' experience safe, they can navigate through it, and the experience is sustainable. However, even the best designed and maintained trails can suffer from issues requiring intervention, including the building of stone structures. But first, let's look at these trail problems, these issues that we encounter. So one is steep trail grades or steep slopes, and that will accelerate erosion and thus making your trail unsustainable. Water management is a major issue. You have to accommodate for drainage and keep water off the trail and at the right speed. Soft or unstable tread needs to be hardened. So an example of soft tread would be muddy or wet areas. Unstable tread could be soil that needs to be retained. So what can we do about these issues? There are really two options. We can either choose to reroute the trail to a different section of the land where we don't encounter these issues, or if rerouting is not an option, we can choose to regrade the tread. We can choose to build drainage structures, sculpt the land somehow, and or we can address them through building structures, which we're gonna look into today. So why do we choose to build with native stone? So native stone is plentiful in many areas. Here, I've included a photo from Sterling Forest, New York, where, you know, this is very typical landscape in upstate New York, North Jersey. And of course, picking any of these rocks is free, you know, as long as you have the permit to build there and everything. And using rocks are durable material to build with, and thus they're sustainable. And depending where you are, they can be very close to transport to the trail to use in your structures. These trail problems that we discussed, they can be solved with timber or wooden structures, but stone has advantages over timber, namely the cost of materials. Also, timber needs to be packed out to your site, which is time and energy consuming. And the lifespan of timber is not as great as stone, even if you're using rot-resistant woods like black locust or treated woods. It's not going to last as long as stone. However, there are cons of building with stone. It's about 200 pounds per cubic foot, I believe. And so the weight of these stones, it causes it, I'm sorry, let me go back. Causes it to be, your work to be time intensive, and the nature of stones, you're working with irregular angles. It's hard to set them in the right position, hard to manipulate them, to make your structure integral. Furthermore, stones may not be so plentiful in areas. They might be difficult to access, not close to the trail. And here's an example of something we encountered, of our trail crew encountered this year, quarrying in high impact areas. So on our Washburn crew, the state biologist deemed unaffected areas. We couldn't take rocks from there because they belong to an endangered fence lizard, or the fence lizard was endangered in the area. So we had to quarry from places way off the trail using a highline rigging system, which that takes a lot of time. So it's definitely a drawback. So I'll let John now go into stone staircases.
Yes, okay, thank you. One of our most commonly used tread hardening structures is the stone staircase. Many of the trails that we work on traverse steep slopes, and that is why we choose to build staircases in these cases. Okay, so here's some of the different components of a staircase. So I'd like to think that there's 4 different components. One not shown here. So the first one is step, the next is the base step, another is the gargoyle, and the last is crush. So with the step, step should be about 6 to 8 inches tall, 11 to 18 inches long, and 18 inches or greater in width. The base step is the first step that is placed and is covered by a few inches of mineral soil. The gargoyles are large rocks that are partially buried along the perimeter of the staircase. They will help stabilize the structure and deter users from walking around the staircase. And lastly, the crush and fill are essentially rocks that we have manually crushed, and they can be used as a base for all these components, or they can be used to fill in gaps between each different component.
Mhm. I just want to add that the base step is there because it helps keep the structure keep its integrity, because when people go down the stairs, they usually put their full weight right as they come off. So the base step is there. So all that weight that's being applied, that compaction is being accounted for. So yes. I'll go next slide.
Let's see. Okay, so the staircase runway is another component of the staircase. So it is a flat or slightly sloped patch of tread between steps. It's used as a break for hikers, or it's also used if the staircase is too steep for the slope. Gargoyles are also still required for this structure, as you can see in this image here. Okay, so now I'm going to talk about some of the important points of contact needed in the staircase. So with the steps themselves, each step should touch the gargoyles on either side, as well as both the step above and below, and this includes the base step. So as you can see in this image here, each red circle/oval shows the points of contact being made by this step. So some important points of contact in terms of the gargoyle. At least 3 points of contact for each gargoyle. So that includes the gargoyle behind it, the one ahead of it, and its adjacent step. There are some cases, as you can see in this top left image here, where the gargoyle encompasses almost 2 steps, and it can even encompass more than that. And in this case, it would have to have contact points with each step that it is encompassing.
So now, now that we've learned about the different components, the different anatomy of a stone staircase, let's look at how you actually plan a staircase out. So what you want to do is measure the elevation or the rise over your distance. So this will tell you how many rocks you need to go X inches in distance and rise Y inches. So I'll now show you a diagram. I'll show you how to do it, the method with a 4-inch level and a measuring tape. So let's look at that. Here's a hand-drawn diagram I made. I used the 50-inch level because that's what we use in the field, but a 4-foot one is more common, but you can do it the same way. Oh, I'm sorry, I have to go back. Okay, so what you want to do is start at the top of your slope and measure, take your level and measure the segments of the rise and the run for each part of your slope until you get to a flat part, and you can see, okay, I have to go 150 inches in distance and rise up 57. So knowing that, as John just explained, we want a height of 6 to 8 inches on each step, so that can help you break it down how many rocks you need to go up 57 and over 150. And let's look at another example here. So in a given area, the rise is 3 feet and the run is 66 inches. That 5 feet is wrong. So we want to locate rocks that will allow you to gain elevation and distance accordingly. So you could do an approach to locate rocks whose approximate rise is 6 inches and run is 11, which would mean you only need 6 rocks to make height. So that's a way you can kind of break up how you plan your stairs, what approximate dimensions you're looking for. I think my partner had to log out because he was having an echo issue. Let me see if I could admit him. You there, John? Give him a minute. Yeah, John? Okay, I will cover his slides. So, let me make sure he's...
I'm back. Can you hear me?
Okay. Yeah, I can hear you.
All right, sorry, there was an echo, so that's why I tried to log back in. I'm not sure if it's gotten any better. Maybe not. I'll continue.
I can hear you okay.
Okay, good. So stepping stones. This is another tread hardening structure. So it provides a surface to traverse seasonally wet or muddy areas.
Hey, John, I think you're still echoing.
Okay, you want to just cover these slides?
You could maybe try to turn down your volume on your speakers or something.
Okay.
I'll cover this slide right here. So stepping stones are a structure used to harden the tread. So it'll provide a sturdy surface for people to traverse seasonally wet or muddy areas. Stones are rearranged so that their flat faces are facing up. About 8 inches are left between stones, and the stones are buried in organic soil, so only a few inches are exposed on top. You want to try this, John?
I think he went out and is trying one more time to come back in.
Okay, I'll do this one. Okay, so this is a structure used to construct tread. It's called the stone turnpike. So the purpose of a stone turnpike is to slightly elevate portions of the tread over wet areas. You use in areas with sitting water, and the benefits of a stone turnpike are it makes the best path for hikers and sustain areas of conservation concern. It also works well for multi-use trails that have livestock and mountain bikers that can't step on the individual stepping stone.
Okay. You want me to try this now, Kevin? Is it echoing?
I don't hear you echoing, but other people might.
I'll try this. So the stone turnpike execution. Rocks are arranged in 2 rows, marking the perimeter of the turnpike. Crushed rocks fill the space between the rows, and then this is all topped and packed with mineral soil. Okay, so one of the drainage techniques that we use is a water bar. I will say as a disclaimer that water bars are not used as much as they used to. Kevin will cover another technique after I'm finished with this called the culvert, and that's more commonly used today. But anyways, so the water bar is used for a variety of drainage issues to improve existing drainage patterns, divert snow melt and seepage, and rain from tread. So the execution of making a water bar, I will say that it can be made using either wood or rock, but rock is obviously preferred because of its durability. So the bar is placed at 20 to 30 degrees angle on the trail. An apron shaped like a funnel, forcing the water to be diverted before hitting the bar. And the outlet ditch is dug out until the water has a place to flow.
Okay, so now I'm going to talk about a rock culvert. It's used to harden tread, and as a drainage structure, it's kind of a multi-solution structure. Um, some people might be familiar with pipe culvert. You might see that in road construction, where there's a pipe underneath a road that allows water to go through. So a rock culvert is similar. They're drainage structures designed to conduct water beneath a trail. Let's look at how to construct one now. So first you want to dig out your area, excavate wherever you're going to be putting your culvert, and lay large flat stones in a trench to start the floor. And on the sides, install large, well-matched stones. And you want to have them wide enough so you can get maybe a shovel spade in there or something that maintainers can clear out debris, because that could cause your structure to fail, your drainage to get clogged. And then to complete a culvert, you span the side rocks with a large flat stone, placed securely enough on top to withstand use. Remember that people walk over this. This is made to be an aesthetically pleasing drainage structure. People can just walk over. They don't have to step over a water bar or something. And you can top it with soil or other earthen material to help keep it more structural. Okay, so now let's talk about crib and retaining walls, which I mentioned before has been my specialty this season. So crib or retaining walls, you can use that word interchangeably, but they are a great problem solver. You can use crib walls to build up on steep slopes to create a new level trail surface behind them, or they can be built to retain a steep back slope just behind or above the trail from eroding onto the trail surface. However, they solve a lot of problems, but they're very time consuming. If we try to mostly design a trail so that we don't have to build walls, because they take a lot of time and energy. So most rock walls built on trails are dry walls. An advantage of drywall construction is that crews won't have to pack out cement and water to the site, but without mortar, gravity becomes the glue. So each stage of the drywall construction, from selecting large rocks to placing them with care, enhances the effectiveness of gravity and increases the sturdiness of the wall. So it's preferred if you can get away with just using a single tier of large rocks, because if you get into multi-tiers, you have to worry about insloping your rocks, battering, and breaking joints, which we'll learn about. And also to note that if your wall is 5 feet and up, that requires engineering. So the first step of a multi-tier crib wall is to inslope your foundation, or this is known as battering your wall. So first, you're going to excavate your batter. So dig down in the earth, and there's different ratios of how much you can lean if you really want to dive more into this. But basically, the main point with base tiers is using large rocks. Here's another picture. Here's a wall that I'm building in Sterling Forest, and you can see this gap right here is that is the batter for my next rock. So it's in slope down, and I'll be able to build another tier on top of it without worrying that gravity is going to push it back, because it's insloped into the mountain. So let's talk about breaking joints now. So breaking joints is just the process of, let me go back, of breaking these gaps. So you can think of it like laying bricks, and here's a photo from the SCA manual that it's very brick-like. So you can see the joints, the gaps right here are broken by this rock, and vice versa. And breaking joints is going to stiffen your structure. Here's another example of a wall we built at Sterling. There you can see where we broke the joints, and there are some running joints. There's always going to be running joints in a structure, but you want to do your best to minimize them because that will not make it as stiff as it can be. So examples of running joints are right here I can point out, and on the sides along here. And we want to do our best to minimize those by breaking a joint at any possible moment. And the last part of a crib wall, you got your base tier, you got all your middle stuff, and now you need your capstones. So capstones, you want them to be very large because all that weight is gonna hold the bottom tiers in place. And your capstones don't have to be flat on top. That was something I didn't, something important I didn't mention in the previous slides, is that specifically too with your foundation tier, you want the flat side to be on top, and your middle tiers, you want them to be relatively flat. But when it comes to your capstones, they don't have to be flat on top. They can be protruding or like a coping stone or something. So yes, so we talked a little bit about breaking joints and contact. John talked about that with stone stairs. So let's look at some different types of contact and what our preferences are. So here's a picture of a crib wall base tier that shows some really good high and outside contact. So this is the outside of the structure here. Here's the inside. So you can see we have high contact on the rock, and there's a plane here that it's contacting, which is going to make it stiffer and stronger. Let's go to the next one. Okay, so here's an example of a low and outside seam. This is the wall we just looked at before. So this particular rock right here, we see it's outside, it's on the outside of the wall, but it's low and it's a seam. So not bad, but that's just an example. Here's another type of contact, a point contact. So here's a couple different views of this wall. So here we could see where the point is contacting. This is the view from the inside of the wall. So this is all going to be fill material here, and this is the point that it's connecting at. It's low and outside, and yeah, this is the front or outside of the wall. There's just some examples of different kinds of contact, and we have sort of a hierarchy of preferences. We prefer plane contact to seam contact, and seam contact to point contact. We want to strive for high and outside contact a lot. Most of the time, that'll make your structures strong. So let's talk about when there are gaps in your wall or in your structures. You always want to backfill your gaps and never shim them. So here's an example of that same wall we looked at before. And this is the inside of the structure. So to backfill this gap, we would put a rock on the inside to wedge it that way, as opposed to here's the front side of the wall. We would never want to push something in there because it'll just get pinched out, wedged out when the weight settles on top of the structure. And now we can talk about just some general overview of stone building practices that maybe we didn't cover in the structures we talked about. So it's always good to quarry more stone than necessary. You don't want to leave yourself with no options, or get married to a rock that's just not going to work. You want to give yourself options. Also, it's nice to measure your rocks before you move them. One, it saves time and energy, most importantly. And like we talked about, we always want to set and fill with crush. And the reason we do that is to prevent frost heave, um, which is a force. I believe it was, I sent it in the homework file that you all got. And like we were saying, it's best in your structures to use the biggest rocks possible, use big dimensional rocks. And you can check if a rock is set if it doesn't move when subjected to a reasonable amount of force. So you can do a kick test. Actually, the SEA manual tells you to get on top of a rock and do a little rock dance, wiggle it a little bit, and if it moves, you can prop it up. Like, let's say it's a base tier and it's wiggling, so you can prop it up, lean it back, and prop it up from the front, but you never want to prop from the outside of the wall because that can just fail. So, and now let's look at some trail problem examples. So here's a picture from one of the trail conference manuals of a really eroded gully, something that needs to be avoided or definitely repaired. So it's time now to show what you learned, and we're going to read off a situation, and then you are going to recommend what type of structure we should build, and you can answer either by putting it in the chat or you can raise your hand and say it with your voice. So I'll read the situation. There's muddy terrain where the trail goes through. The primary users of this trail are hikers, and there will be only foot traffic, no bikes or livestock, and there are many large boulders slightly off trail. What type of stone structure would you recommend? So I'll give everyone a minute or two to answer or raise their hand. Keith says a culvert. Nice. So what did you all say? We got some stepping stones, stairs. A couple people said a culvert. The answer is stepping stones. And the big hint at this situation was that it's only for foot traffic. So, and some of these, these are simple situations, but obviously we don't know the full context of the trail. There could be a drainage problem, but yes, let's go on to, someone said, oh, sorry. Okay, yeah, let's go on to the next situation. So, in a given area, the soil is saturated and somewhat eroded, but unfortunately the trail cannot be rerouted. This trail needs to accommodate hikers, bikes, and livestock. Fortunately, there's plenty of stone nearby. What would you recommend? Oh, I should be more specific. What type of stone structures would you recommend? That's my bad. Nice. I'll give you 30 more seconds. Very nice. Okay. Adrian and Helen say a culvert. Brian, Lori, or sorry, Brian, Walt, and Helen say a turnpike. We got some culverts. Well, in this situation, we would say stone turnpike, just because of the nature of the scenario. However, saying culverts or other type of draining structures is totally valid, and depending on if you add more context, obviously these are simple situations, that could be a problem. There could be a drainage issue. So all good guesses. Okay, this is the last one. This is for the prize. I don't have a prize, but you get to brag. Oh crap, I just showed the answer, I think. Anyway, you just pretend you didn't see it. You're maintaining a current trail that ascends to a viewpoint. The current trail to the vantage point is steep and eroded, and it's starting to trench. What type of stone structures would you recommend? This one was easy anyway, come on. If someone gets this wrong, then you're just lost. Had a trigger finger. Yep, everyone is looking like they're getting it right. Stone stairs, and you could also say that well, stone stairs can be combined with crib walls. So sometimes these problems we encounter have multiple solutions or a combination of structures that can address the problem. So right now we're just going to open up the floor, and feel free to unmute yourself or raise your hand, type in the chat. Give us some questions, whatever's on your mind. If you need me to explain something in a little bit more detail, I can do that. And I'll leave the floor open to questions, but if there are none, thank you all for coming here. It was really nice to teach you all. And oh, here we have some questions. What is the maximum height? Adrian says, what is the maximum height of a retaining wall? So for what we do, we cannot build above a 5-foot wall without it being engineered. And if Ben wants to jump in and give more of an explanation for that, he's welcome to. How high can you make a raised walkway? That's a great question. I don't know. I'd have to put that off to Ben. I guess it depends on what kind of structure. If you're doing a punch-in, a boardwalk, I'm not sure about a stone structure. If Ben is there, Ben, I know you're out there, even though you're incognito. Or Tracy's here, right? Tracy can jump in.
I'm here now. Hold on a second. So the issue with wall height with an unmortared wall using natural components. Sorry about the echo. It has to do with you need an engineer beyond a certain height because the forces involved in terms of the material being held back. The force becomes too difficult to eyeball with our standard building techniques, and you need more calculations to ensure that it's safe. Also because the consequences of failure are usually more, I don't want to say catastrophic, but they're more significant with higher. Does that help?
Cool, okay. Let's address some of these other questions. Ben, do you know how high? I think Lori is referring to a stone turnpike. How high can you make a stone turnpike?
Don't build any structure so high above the prevailing area that people will be tempted to walk around it. So theoretically, you could build it as high as you would any stone wall. So up to 5 feet, but you wouldn't really typically want to. And we wouldn't build turnpike in something that is an actual wetland, say a marsh or a swamp, because of the regulations behind that. We're talking about crossing small muddy areas typically. If it's a very commonly wet area, you're looking at bridges or boardwalk, which we don't build stone bridges these days. It's inefficient. So we go for lumber in that case.
Nice. Someone asked a good question. Something that I forgot to go over on my crib wall section. How could I forget? How thick should a wall be? So your wall should be half as thick as it is high. So if your wall is 3 feet high, it has to be at least 1.5 foot thick, but it also scales down. So like a 1 foot tall wall should be at least a minimum 1 foot deep. So that was a good question. Brian had a question. Can I unmute? Yes, Brian, you can unmute yourself if you want. Go ahead. Do you want me to unmute you?
I think it's set so people can't unmute.
Oh, okay. Am I on?
Yes, we can hear you.
Choosing stones for a wall where you want them to fit against each other, nothing is ever perfectly flat. How do you visualize where the next stone is going to fit without rocking because of only having point contact?
Right. You want me to try to take this one first, Ben? I'll try to take it. So you can approach it several ways. You can just have an eye for how the angles are going to line up, or you can also we do a lot of shaping of rocks, so using stone busters or diamond blades if we need to shape rocks in order for them to get fit. I don't know if that answered your question fully.
Yeah, what is a stone buster though?
It's a single, almost like a hammer thing. It has like a carbide tip on it. It's like a chisel used to, and you
Otherwise
put
known
that,
as a stone hammer?
I think it might be called that. I don't know. What do you think, Ben? Or you can't unmute.
Yeah, it's just a more specialized type of stone hammer. It has a carbide on it, as Kevin said. There's different tools you can use for shaping stone. If you're interested in dropping some coin for shaping stone, Trow and Holden in Barrie, Vermont sells specialty stone shaping products. Typically, you can use, some of the chisels and things you find at Home Depot, but with the hard rock, it's granitic gneiss that we have in this area, you're going to want carbide for doing any sort of extended stonework. But, you do pay a little bit more of a premium for the stuff with carbide. You basically, just to add on in general, you do the best you can with the rock you have. You're not always going to have perfect cubes or slabs. I've seen, rock wall built in, places in like Scotland where it's all river rock and it's all round, and you know they set it as best they can, and they you know they break a lot of the principles of wall building, but they still get it done. It's not ideal, but it works. So what I was taught is there's something like 13 principles of building rock structures, and on any given project you're going to break 6 of them. Just don't keep doing the same ones over and over.
Lori, you had a question. Are you able to unmute yourself?
Yeah, am I unmuted?
Yes, we can hear you.
Okay. I wanted to know how you learned to work with stone. I mean, this is not the first place you started working, right?
Actually, I've done landscaping positions before, but this is my first experience with dry masonry.
Really?
Yeah.
Oh,
But you were asking, yes, your hands can hurt a lot after a given day. You're especially when you're using tools like rock bars and when you're using hammers to make crush and set your rocks. Yeah, you can develop joint problems if you do repetitive motion too much on any given task.
just
Lori, I've been doing this. I got my start in AmeriCorps just like Kevin is doing now, and that was 17 years ago. I have had carpal tunnel release surgery in my right wrist, and I'm probably going to have it in my left wrist in the next year. So it is a little tough on the body to do it consistently, but for short bursts, it's fine.
Mhm. Oh, I like working with rock, but I'm a little older than you guys. I'll need carpal tunnel too. Thanks.
Adrian asks, is it better to try to trim a rock at the risk of weakening or creating fractures that may cause a failure in the future, or spend the time looking for a better fit? I mean, it depends. I think more people are more risk prone. Some people want to take more risks. Some people, yeah. Sometimes if you have the perfect rock, and you don't want to, or you have one that can shape into a really perfect spot, and you're too nervous about hammering it. That's why we use the diamond cutter blade to get a more accurate cut. Yeah, and it's all about risk and reward. So do you want to spend more time looking for a better rock and transporting it farther, or do you want to take the risk trying to shape it? Brian says, Ben, were you talking about 13 principles?
It's not literally 13 principles. I had a little write-up of what I consider some of my principles. You covered almost all of them. I'm just going to paste them here in the chat. So, yeah, the only one that you didn't cover is that any fill you use, you fill in the back. The fill has to be protected from washing out or outside forces. But pretty much everything else you covered.
Any other questions for myself or for Ben? Or John, if he's still here. Okay, if there's no more questions, then...
Did you answer Adrienne's question?
Oh, I'm not sure. Maybe you could address it. I don't see it.
I think you could do. Is it better to try and trim a rock at the risk of weakening or creating fractures that may cause a failure in the future, or spend time to look for a quote better fit?
I think personally, I've gotten pretty confident with my shaping abilities. Once you start to work with this granitic gneiss that we are, you can, I mean, it's unpredictable, but you can start to, there are certain techniques like cutting with the grain, or if there's like a shelf or something, you know, you can hit it from the top to kind of make it fracture and a ledging kind of a way. But yeah, personally for me, I like to take the risk of shaping more. But that is a good question. Thank you, Adrian. Okay, thanks everybody. If there's no other questions, I'll hang back for a little while if anybody wants to ask anything else. But if you're interested in signing up for more events, you can go to nynjtc.org/events. And if you're interested in volunteering, you can go to our website or email us at volunteer@nynjtc.org. And thank you all so much for coming out.
Just before you go, Guy, what does the arrow mean on your list here?
Oh, hold on a second. Let me scroll back up. It means better than. You know, it's a preference list.
Oh, okay. Mm-hmm.
Yeah. So crushed rock is preferred to soil.
Good. Thanks. And when we finish up, will I still be able to work on writing down this list, or are we going to lose it at the end of the Zoom?
What I would say, so in the bottom right-hand corner of the chat, there is a little button with like the three ellipse, the three dots.
Yeah.
That will give you the option to save the chat. Or you can highlight it all and hit Control-C and paste it into a Word document.
Oh, and should we also mention that this presentation is being recorded and it'll be available to them?
No, you shouldn't mention that. I'm pretty angry that you told me. No. Yeah, basically there's an entire digital library of our webinars online. If you search NYNJTC webinar library or something like that, you will see a bunch of these courses, and in fact some of you are grizzled veterans of some of these sensibilities. All right. Great job, guys.
Thank you, everybody. Thank you, Ben or
Thank
Guy.
you.